So, hello and welcome to lesson number 1, chapter 4, Vellum in Motion. Here are again, some just 2 wireframes. So, we will get started now. I can close them, don't save. We'll start with, like a simple basic Vellum simulation to get an idea how the whole Vellum simulation system work, and after that we will build then up the smoke simulation to then advect our Vellum simulation, and then we will further process it, and of course in the end of that chapter we will do look development or rendering lesson 2. So let's get started. First of all, I will start as usual with a simple geometry container, and in this geometry container I will first of all I will rename it. So maybe GeoVellum or Vellum in Motion. Vellum in Motion. Cool. So we will dive into that. So with double click or I on your keyboard, and we will place our first sheet or piece of fabric. There are several ways you can do that, but I usually go for like simple geometrical shapes. I will go for just a planar patch. This is the simple planar patch. You can of course ZX plane, for example, on the build plane, so on the side distribution. I usually change it, but of course it will depend on your simulation style, or maybe you got colliders and so on, and then you of course can play around with the orientation, and of course place a transform under that and play around with that. So usually I go with the planar patch because you can just simply get more resolution over the edge length. The cool thing is you can play around with the shapes here. So for example a ring, a full ring will be 360 for example. You can do a half one, 180. So these are pretty cool because you got the shapes, or you will get the shapes quickly done. But another node that I like to use is the planar patch from curves. So this of course will have an input. A shape curve to fill with patch. So that's pretty straightforward. Placed on a curve node. And with the curve node, of course, we can draw something. For example, let's draw a heart shape. Oh my god. So something like that here. Oh my god, that's beautiful. Okay, cool. And of course, resample it. Yeah, that's a beautiful heart here. Let's go with something like that. So that's nice. And you can just then feed a curve into the planar patch, and you will get, when you get the build plane right, let's go for resample it. So resample curve, and for example then you can dial up the resolution. So simply from curve input you can do a lot of cool things. Another cool thing to do is, what you can do, place down a circle, a polyframe and a mountain, and we will lay them all out here like that. The circle will go in the ZX plane direction or orientation. Type is polygon. You can choose I think closed arc will work too. But let's go to the polyframe, and we want the tangent to be the normal. And let's get them more resolution. So like that here. And with the mountain, we will then basically displace it along the normal, but because we modified the normal based to the tangent, you will get this flat modification. It's pretty cool for generating other kind of maybe stuff for environmental things, or maybe even crystals, minerals, and so on. And then you can feed that, for example, into here, and you will get, let me just place a normal down here, and you will get a pretty cool quickly displaced form, basically, with a minimal time input. And you can use that, for example, for a fabric simulation, because of course your initial fabric simulation or your end result of the fabric simulation will always depend on your initial shape. So try to come up with different shapes, maybe shapes layered on top of that. We will do that, of course. And yeah, just try that out, for example. So circle, polyframe, mountain, planar patch from curves, normal, done. So for example, for this kind of shape here. Cool. But we will start now with the planar patch. For the size, let's go for, I will do like a longer shape, maybe for 5 and 2. And of course the edge length, I will go back to 0.085 or even 0.5 to get a little bit of a better resolution. So the planar patch, now I choose like a size from 5 and 2, and the edge length 0.05 to get a little bit resolution. Of course we need UVs, so UV texture. Here's several ways, but you can just use rows and columns, and for visualization you can use the labs UV visualize, or you can use the quick shade, so that will both do the job. Or you can use, of course, the labs auto UV, that should do the same thing. Auto UV, let's pipe it in here. Yeah, okay, basically the same. So let's just disable that. Yeah, okay. So UV texture, rows and columns, finished. Don't make it too complicated for simple UVs. So now we got our simple fabric laying here flat on the ground. And what I want to do, I want to place down a null and call this initial cloth. Whoops. Let's make the in big in caps. Okay. So this is our for our cloth simulation, and then we need to convert this into a vellum cloth. So we will place down a vellum CC, so vellum configure cloth, and we can pipe that, and now you can see we created some attributes on our piece of fabric. So for example, mass, p-scale, track tangent, track normal, and so on. And what we will do, we will pipe that thing in a .NET, where we will build our vellum simulation. So geometry first input, and the constraint geometry into the second input, and then we can basically just dive inside here, and you will see nothing because of course we need to set up our solver. We will need a Vellum Solver, so connect that here. Vellum Solver into the output input. the output input, and then of course we need to solve something, and we will need to solve a Vellum object. So place down a Vellum object and just pipe it into objects to solve. And now you can see we already get here a visualization, or we successfully imported our fabric sheet or fabric geometry. And now we got here all your common parameters. So for example, substeps, dynamic scale, time scale for slow motion, for example. And then we can place on a pop wind here, and pipe up the amplitude, maybe to 1. And you can see we already got our first simple Vellum simulation. Of course, that's pretty simple. And what you can do after that, place on a Vellum post-process. We will use that later, of course, too, or we will just leave it here. Blur, you can use that, for example, to blur out a little bit the geometry. Detangle, if you got like collisions, so that will try to solve the detangled collisions. And extrude by thickness or thickness scale, you can extrude basically your Vellum sheet, because of course a piece of fabric always will have a thickness, even if it's like 1 millimeter or even thinner. And you can, for example, extrude that a little bit. So for example 0.25, and then subdivision loop. You can loop it, so make a subdivision to get higher geometry, so to pipe the primitives a little bit up. After that, in the next part we will go with the smoke simulation, and we will delete some of the attributes here because we will really don't need them. But that's like now our first simple simulation. Of course, it's nothing fancy, but it will work out for us. It will get prettier and better with the smoke, so we'll do that in the next lesson.